In this video, we're going to work on the ALEKS problem called naming and drawing simple substituted cycloalkanes. There are two different versions of this problem. This is one version where we have been provided with three different structures and we're asked to come up with the name of each one of these three molecules. Let's do this version of the problem first. I'm going to start with the second molecule. That's the easiest one to name. When we are naming cyclic molecules, our first job is to number the carbon atoms of the ring, and we want to number the carbon atoms in such a way that our substituent or substituents gets the smallest possible number or smallest possible set of numbers. This molecule only has one substituent, which means that we are going to say it is located on carbon number 1. Remember, our goal is to put the substituents on the smallest number. So of course, we want that to be on carbon number 1. Once we have numbered our ring, we've got to figure out the names of our substituents. This is a 1-carbon substituent. 1-carbon substituents are called methyl. And now we're ready to put the molecule's name together. We're going to locate the substituent. It's on carbon number 1. We're going to name the substituent. Its name is methyl. We always separate numbers from letters with dashes. There's no spaces anywhere in there. It's just 1 dash methyl. And once we've got all of our substituents located and named, we are going to name the parent chain, which in this case is a cyclopentane, a 5-membered ring. Just like that. Let's do the first one next. So this one, we're looking at a 6-carbon ring. That's going to be a cyclohexane. We have 3 substituents. All 3 of these substituents are identical. All 3 of these are substituents with 2 carbon atoms. A 2-carbon atom is called an ethyl. And because this molecule has 3 identical substituents, instead of saying ethyl, 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 we are going to use the prefix tri, which means 3. I really spaced that out weird. And we're just going to say triethyl. This means that we have 3 ethyls in the molecule. Now, again, our goal for numbering this ring, our goal is to come up with the smallest possible set of numbers to use as the locations for the ethyls on this ring. And this may take a little bit of trial and error when you first start doing this. So, for example, you might initially think this is the best way to number the ring, like that. If we number the ring this way, our ethyl groups are on carbons 1, 3, and 4. That looks pretty good. But that is, in fact, not the best way to number this ring. I'm going to just, in the interest of time, I'm going to jump straight to the best numbering system, which is going to be this right here, 1, 2, 4. How do I know that one is better than the other? Well, first of all, because they both have a 1 and a 4, but one of them has a 3 and the other has a 2, which by default makes this a better set of numbers. But if you're having a hard time finding the best possible set of numbers, one of the things you can do is add your numbers all together. 1 plus 3 plus 4 is 8. 1 plus 2 plus 4 is 7. And because 7 is smaller than 8, that tells us that this is overall a smaller set of numbers. And this is the one that we should go with, which is what we're going to do. We're not going to use that one. And again, finding the best set of numbers for the ring, it just takes a little bit of practice, a little bit of trial and error. Now we're ready to put the molecule's name together. We've got 3 identical substituents. We're going to start off by locating them on carbons number 1 and 2 and 4. We use commas to separate numbers, no spaces anywhere, 1, 2, 4. Then we're going to say the name of those substituents. There are 3 of them, so we're going to say tri. And their name is ethyl, 1, 2, 4, triethyl, and then the name of the parent chain, cyclohexane. Now, last but not least, down here we have another 5-membered ring. This one maybe is a little bit easier to see the numbering. We're just going to go straight across, 1, 2, 3, like that. Now, if you were saying, oh, what if I went 1, 2, 3? That's exactly the same. 1, 2, 3 left to right versus 1, 2, 3 right to left is going to give us the exact same name. We have 3 different substituents on this molecule, or 3 substituents, 2 different types of substituents. We have a chlorine as a substituent. We call that a chloro. And then we have 2 methyls in this molecule, 2 of them. To indicate the quantity of 2, we're going to use the prefix di. That means 2. And that is a single carbon substituent, so that's a methyl. are ready to put all of this together in the molecule's name, we need to alphabetize these substituents. So we're looking at the name of the substituent, and we're alphabetizing the name of the substituent. The name of the chlorine substituent starts with the letter C. That's going to be alphabetized as a C. Here, we are looking at the name of the substituent. The name of the substituent is methyl. Don't be confused by the di. The di is just telling us the quantity. We are alphabetizing our substituents by their names, chloro versus methyl. Chlorine comes first alphabetically, so it is going to come first in the molecule's name. It's located on carbon number 2, 2-chloro. And then next we have our methyls on carbons 1 and 3. Dimethyl, and then we have cyclo, 5-membered ring, so cyclopentane. Now, like I said there at the beginning of this video, there are 2 different versions of this ALEKS problem. So let's go to ALEKS and see the second version of the problem. The other version of this problem is that it gives you a name of a molecule and it wants you to draw the line structure for that molecule. So the name that's been given to me, is 1-chloro-2,4-dimethyl cyclohexane. When I'm being asked to draw the name of a molecule, I usually start at the end of the molecule's name. So the first thing that I'm going to draw is the cyclohexane. That is a 6-membered ring. Ooh, and I am doing this on an iPad, and ALEKS drawing is not super iPad friendly, so we'll see how I actually do here with this. I might need to reload this problem. Let's see if this works any better. So here we go. I'm going to draw a 6-membered ring like that. And then once I have that 6-membered ring in place, I'm going to put my substituents on it. I'm going to go back now to the beginning of the name. Now the name tells me I have on carbon number 1, I have a chlorine, and I get to choose which carbon is carbon number 1. So I'm just going to pick right there. I need to make that a chlorine, so I'm going to tap the ending of that line that I just drew, and that gives me an opportunity to place a chlorine atom at the end there. And then it tells me the next part of the name is 2,4-dimethyl. So that means on carbon number 2, I have a methyl, and then also on carbon number 4, I have a methyl.